this theorem. We have to make sure that the function f is continuous on the interval, it is positive on the interval, and it is decreasing on the interval. Now, that part in itself could take a little bit of work. Integral test is quite a bit of work, because once you've proven all three of these pieces, that means you are now allowed to do the integral. Okay, which in itself, as we all know, can be a bit of work. I'd like to start off with one of the most famous integrals involved, or I'm sorry, power series involved. By the way, this part of it here is the conversion from a discrete function to a continuous function. Okay, and we already talked about what that means, but to do an integral of any kind, we have to be able to make it continuous. That's not true at a super high level, but there are ways of doing that. But for our purposes, we're going to make it continuous. What is a sub n in this case? 1 over n, right? Okay, this is, by the way, called a harmonic series. I mentioned this last time. We did the test for divergence on this one. The limit went to 0. We go, oh, we don't know what that means. Could be convergent, could be divergent, we don't know. We are going to use the function f of x equals 1 over x to mimic what it is that we're trying to do. The interval that we are interested in is not the entire domain of this standalone function. We are only interested when it starts at 1 and goes off to infinity. Okay, so now let's explore this. On the interval, x goes from 1 to infinity. Is f continuous?
Yes.
It is. Okay, and let's keep in mind what the graph looks like. Alright, it starts at 1, it goes. So f is continuous. I need to see that. Next up, is it positive on x equals 1 off to positive infinity? Yeah. All the terms are always going to be positive. The graph is always above the x-axis, right? We don't have an issue. Back here we have an issue, but that doesn't apply here. Now, as far as decreasing goes, we can look at this particular graph and say yes, it's decreasing. However, I want to be a little bit more exact, because we may run into a function that we don't know what the graph looks like, and we don't know if it's decreasing. If you think back to Calc 1, there's a way to tell if it's decreasing. If the slope is negative, then it's decreasing. You can picture this. Negative slope, right? I should go this way. Negative slope. If the slope is negative, then it's decreasing. So it's positive, it's increasing. We learned that in Calc 1. So let's see what the slope of the tangent line looks like. So for any value of x, do you see that this will always be negative? So this is decreasing. On this interval here. So we have satisfied our three axioms. It's continuous on the interval, it's positive on the interval, it is decreasing on the interval. We now have permission to use the integral test. Okay? If any of these pieces fail, we can't use this test. If any of these pieces fail, use the test for divergence. More than likely, it's not going, the limit's not going to go to 0. Okay? So now we can use the integral test. The integral test says, if this integral is convergent, then the series is convergent. If this integral is divergent, then the series is divergent. Let's try it out. Can I jump right into the integral? What do I have to do? I got to convert it to a proper integral, right? Yeah, the t thing. Exactly. Now that I have a proper integral, I can actually integrate it. What's the integral of 1 over x dx? Forget your Doro. So that's 1 to 1 again? Oh, that's right. What's this limit go to?
It's a beer bottle.
What does this limit go to? It goes off to positive infinity, right? It's doing this. So because this integral is divergent, the summation, the series, is also divergent. So a harmonic series is divergent. We will be using a harmonic series a lot. So remember that. Harmonic series is divergent. Questions?
What does that mean?
That means when I add up 1 plus 1/2, I add all infinity of those up, I'm not going to get a specific value. It's going to go off to infinity. Yes?
Where are the 3 dots?
Therefore. Anyone else? Yes?
What is the application for it?
Application for it?
Give me an app.
You'll see at the end. Yeah, I'm kind of giving you all the bits and pieces we need, and we're going to do a big project on it, and then we're going to do power series, which is what it's building up. So power series, that's the application. Which we don't know what that is yet. All right, let's do another one. All right. let's try this one. Take your time, walk through the 3 axioms and so on. Please be sure to closely explore if it is in fact decreasing or not, even if you're pretty sure that it is. Meaning, I want you to try the first derivative test.